Today in the class we are going to discuss about the measuring and testing instrument. The measuring and testing instruments such as the instrument ammeter, voltmeter, wattmeter. It is all the instrument for measuring purpose. The ammeter. Ammeter. The ammeter is of a very low resistance instrument which is connected in series with any circuit. So ammeter is a very low resistance. Their internal resistance is very low. This instrument is connected with the circuit in series. The current under measurement, and due to low resistance, the voltage drop across the ammeter. The voltage drop across the ammeter and low power absorption is very low, so that it does not change the current flowing through the circuit. So the ammeter is always connected in series with the load. Suppose is a circuit, a, is a ammeter is connected with the load, the load in series. Here the supply voltage, the supply voltage is the ammeter is connected to load in series. Load is the ammeter. The ammeter. The ammeter is measured the current of the circuit. The unit is ampere. Second is voltmeter. Voltmeter, and voltmeter is of the high resistance instrument which is connected in parallel with any circuit. The voltmeter is a high resistance circuit, high resistance instrument which is connected in parallel with the load. Their internal resistance is very high compared to the ammeter. Uh, the voltmeter is connected to the load with a parallel. The due to high resistance, the current flowing through it, the power absorption is low. So the voltmeter is always connected in parallel with the load is measure the voltage of the circuit in volt. Suppose is a circuit, is a load, is a load, the load and the supply system. The voltmeter is connected across to the load, or it is connected to parallel with the load. Here on the supply voltage is a voltmeter. Next is both ammeter and voltmeter connected in a circuit, and the ammeter is connected to the load. Here it is a load. Here both ammeter and voltmeter, those are connected. Load is ammeter, it is voltmeter. terminal of supply voltage, supply voltage. This figure is connection of voltmeter and ammeter. What will happen if the ammeter is connected in parallel and voltmeter in series? We know that the ammeter is connected with the load in series and voltmeter connected is in parallel. If we the ammeter is connected in parallel and the voltmeter connected in series, then this time ammeter has a very low resistance. We know that the ammeter has a very low resistance, very low resistance. If we connected it in parallel with the supply, according to the Ohm's law, it will draw the very high current and the meter will be burned out. We know that the internal resistance of the ammeter is very low. Then this time the ammeter is connected ammeter is connected in parallel. The high current will flow through this ammeter due to the presence of low resistance. Therefore, the ammeter will burn out. Now, voltmeter has a very high resistance. Voltmeter has a very high resistance. When it is connected in series, the total resistance of that circuit is increased. If we connected the voltmeter in series, then this time the total resistance of that the circuit is increased. According to Ohm's law, it will draw the very low current. Due to present of very high resistance, it will draw the very low current, so meter will not give any reading. So voltmeter did not will not get any reading from voltmeter. The voltmeter is not suitable use as a ammeter. Can ammeter use as a voltmeter? The ammeter of low range can be used as a voltmeter by connecting a high external resistance in series. Can ammeter use as a voltmeter? A ammeter of low range can used as a voltmeter by connecting a high external resistance is in series with it. A ammeter of low range can be used as a voltmeter by connecting a high external resistance in parallel with it. Suppose this is a ammeter where the external resistance are connected across the ammeter. The input current I is the ammeter current is the shunt current. The shunt resistance. A low resistance shunt is connected in parallel with the ammeter in order to measure the greater current that the meter itself can carry. Next is extension of voltmeter range. Next is extension of voltmeter range. How to extend the voltmeter range? And extends by using multiple resistance. To increase the range of voltmeter, we can connect the non-inductive resistance in series with the meter. Extension of voltmeter range. To increase the range of voltmeter, we can connect a non-inductive resistance in series with the meter. Suppose here the connected voltmeter with the series resistance. The supply voltage supply voltage and the voltmeter. We get the reading here on the voltmeter, and here it is the external resistance connected within series. Here dropping voltage V minus V suffix V, supply voltage minus supply voltage minus voltmeter reading voltage. After this we'll get the dropping voltage of resistance.